Attention students, please, today we are taking some questions, likely examination questions for this year's WAEC Senior Secondary Certificate Examination, SSC. I'm not saying that this is the question that WAEC is going to set, but we are taking questions, past questions on the volumetric analysis of this year involving H2SO4 and sodium hydroxide. Now, the type 1 question, this question is from one of the years, I think is 2008. Now, in this question, normally you are going to be asked to do the titration. You'll be asked to do the titration, put the acid in the burette, then you pipette the base and titrate it against the acid. Then you'll be provided information. Some information will be provided by the acid and the base, or any of them. As in this question we are told A is 0.103 mole per dm cube of acid HYX. In this type of question, the name of the acid is hidden, and the formula of the acid is hidden. So very likely they may want you to get the value of X and the value of Y. Now we are giving the concentration of the acid in mole per dm cube. Then B is a solution of sodium hydroxide containing 0.025 mole per 250 cm cube of solution. Then from your results and information provided, that's how the question always goes. You calculate the amount of acid in the average titer. Then 2, amount of base in 20.00 cm cube or 25.00 cm cube pipetted. Then number 3, mole ratio of the acid to the base. Then the 4th question, we have to write a balanced chemical equation for the reaction between the acid HYX and the base sodium hydroxide. Then the number 5 question, we should state the basicity of the acid. Now, in this type of question, whenever you are asked to get, you can see a list of formulas here. We have number 1 to number 7. 7 formulae here for titration. These are the main formulas that you need for titration. Now, whenever you are told to look for amounts of a substance, amount is the same thing as number of moles. The amount is the same as number of moles. That's what it means. If you have to look for number of moles of acid, you have to look for the amount of acid, it means the same thing. Amount of acid, number of moles of acid, it means the same. Of course, you know in physics, there are 7 fundamental quantities. One of them is amount. And amount is in what? Moles. In physics, how many fundamental quantities do you have? 7. One of them is what? Amount. Is it not? And what is the unit of amount? Moles. It means that amount is the same thing as number of moles. Now, whenever you have to look for the amount of the base and the acid, this use formula 1 and formula 2. Now, Na stands for the number of moles or amount of acid. Ca stands for the concentration of the acid in mole per dm cube. Then Va stands for the volume of the acid in cm cube, because if you look at the values we have on the board, the Va is going to be in cm cube because we measured in cm cube, so the Va is going to be in cm cube. That is why, listen, that's the reason you have over 1000 here. Assuming the volume is already in dm cube, you don't need to divide by 1000. The same thing goes for the base. Now, for question number 1, please get me the duster. Where is the duster? Where is the duster? Where is that? Thank you. Bring it. No, that is not the duster. Where is the duster? Where is the duster? I continue with the video. Now, the first thing to do, listen. Those of you that want to be serious, be serious. If you want to play, play. Now, the first thing to do, the question will always end by saying from your results and information provided. Before you go into any calculation, first get your results ready and your information provided. Now, there are two things you can get from your results. You can get VA and VB. Now, VA is going to be gotten from this table. Is this table, this titration table, that's where you get your VA. Now, you will normally be asked to look for the average volume of acid used. It's the same thing as average titer. Average volume of acid is the same thing as average titer. And that will be your VA. And the VA, you don't use the raw for your calculation. You use the other two values. So it means you are using 12.120 and 12.10. So 12.2 plus 12.10 all over 2. If you are using 3 values after the rough, you divide by 3. So that gives us 24.30 over 2, which is 12.15 cm cube. That is our VA. We are trying to get down some information from our results. Now, another thing you can get from your result is VB. What is VB? VB is 25 cm cube. That's the volume of the pipette that is used. It's 25 cm cube. So your VA is from this table. Your VB is from the pipette. There are two types of pipette, 20 cm cube and 25 cm cube, but we are going to use 25. So your VB is 25. Then these are the two values you can get from our results. Let's go to the information provided. The question reads, A is what? 0.103 mole per dm cube of acid. So what does this value stand for? It stands for CA. That is concentration of the acid in mole per dm cube. That's what it stands for. 0 mole per dm cube. But they may adjust the value there in the whatever they do. It's the same process. The calculation is always done in this direction. WAEC will decide to adjust the value so that it does not look like what you have done already. So now, this is 0.10. Then what else can we get from the information provided? This is a solution of what? Sodium hydroxide containing what? 0.025 moles per 250 cm cube of solution. So this 0.025 moles, what does this stand for? It stands for number of moles. That means number of moles of the base. That is 0.0. Is this 0.25? 0.25 moles. Then you are given the volume. This one is the one that is given. We are given volume of B, 250 cm cube. Then what else are we giving? Is there any other information provided? There's no other. This is all the information provided. So these are results, and that's the information provided. Now, what do you do with this information provided? Whenever you have number of moles and volume, what you have to do, you have to convert it to concentration in mole per dm cube. You have to convert it to concentration in mole per dm cube. Concentration in mole per dm cube is what? Amount over volume in dm cube. There are two ways you can get your concentration in mole per dm cube. You can use concentration in mole per dm cube is amount over volume in dm cube, or concentration in mole per dm cube is what? Concentration in gram per dm cube over molar mass. But in this case, you cannot use the concentration in gram per dm cube because we don't have it. So that's why we're using this one. So now we have to divide this volume by 1000. So that is 0.25 dm cube. So that means our CB is going to be 0.025 over 0.25. So 0.025 over 0.25. What do you have? We have 0.1 mole per dm cube. That's our CB. Then we can go on to answer the question. The first question here is what? Amount of what? Acid. Amount of acid in the average titer. Don't forget that average titer is the VA. So the formula to use in this case is Na is equal to Ca VA all over 1000. The reason is because the average titer is in cm cube. So what is our Ca? 0.103 times the VA 12.15 all over 1000. Look at it. We are told to look for the amount of the acid in the average titer. This is the formula for looking for the amount of the acid. So your Ca is already there. Look at the Ca here. Your Va is the average titer, average volume of acid. Look at it, 12.15. So that's it. You multiply the Ca by the Va, divide by 1000. So what do we have? 0.103 times 12.15 divided by 1000. That gives us 0.00125 moles. That is 0.00125 moles. Then that answers question number 1. Then question number 2, we are told to look for the amount of the base in what? 20.00 cm cube or 25.00 cm cube pipetted. This question can also be reset in this manner. You can say you can be asked to calculate the amount of base in the volume pipetted. Do you understand? And what volume was pipetted? What is the volume of our pipette? It's 25. So we are using 25. So the 20.00 is for those schools that use 20 cm cube pipettes. But for us, we use 25. So now that means our CB is going to be, our NB, which is amount, is going to be CB VB all over 1000. So what is our CB? 0.1. That's what we have calculated before. Then our VB is 25. VB is the volume of look at this now. That's why we are dividing by 1000. Because it's a cm cube, we don't want to bother ourselves converting to dm cube. So you divide by 1000. But if you can divide this and convert it to dm cube, from this point, if you divide and convert to dm cube, divide this one, convert to dm cube, then you don't need this 1000 here. You don't need the 1000. You don't need the 1000. But when you have not divided it by 1000, then you have to divide. So what do we have in this case? 0.025 moles. So that is our number of moles. Please pay attention. Your amount of acid, use this formula for amount of acid or number of moles of acid. Then use the next formula for number of moles of bees or amount of bees. Then the next question that usually follows when in this type of particular question, the next one that usually follows is you will have to look for what? The mole ratio of the acid to the base. So the mole ratio of the acid to base, see the formula for mole ratio. The mole ratio is Na over Nb. That's the mole ratio. The mole ratio is Na over Nb. Whenever you ask to look for mole ratio, you already have your number of moles of the acid, you have your number of moles of the base. Then you now divide the number of moles of acid by that of the base. So number of moles of acid is 0.00125 all over number of moles of the base 0.0025. Now which of these is smaller? Which of these two values? It's not 25. How many decimal places do we have up here? No, here for the number of moles of the acid, how many decimal places? There are 5 decimal places. Then what about the base? And so you want to know the difference, add one more zero here. So you think because 25 is smaller than 125, automatically the one down is lower. They must be equal number of decimal places. Now, if you look at it, you see that 125 is smaller than 250. So that means you are going to divide by the smaller one. So if you divide this by 0.00125, you are going to have 1. Divide this by, you are going to have 2. So therefore, the mole ratio is equal to 1:2. So you can write that down, it's 1:2. That's the mole ratio, it's 1:2. Then you divide by the one under. Because the mole ratio must be in simple one number ratio. You always divide by the smaller one, but for this practical, the one up will always be smaller than the one down. Yes, but if you are doing any titration and you have to look for the mole ratio of the acid to the base, and you find out that the base is smaller, and you divide by the smaller value, that's the only way you can get it in whole numbers. Divide by a smaller number. I know what you are saying. You are asking, assuming it's the base that is smaller, and you divide by the value of yeah, to divide the other one. So that means this one we can use one to divide. Yes. No, you don't understand what I'm doing. Assuming I have to cancel. Now listen. Assuming I have to cancel. If I remove the decimal points, what do we have? If I remove the decimal points, what are we going to have? And we have 0.00125. Controller is asking a lot of questions. I don't know whether I do not know how to reduce to lowest things. Then remove the decimal point from the other one. You have 0.00250. Cancel these 3 zeros before them and reduce to lowest end. 125. Assuming you want to reduce it to lowest end, what would you use to divide? You know 125. Then why are you now asking questions? 125 divided by 125 is 1. 250 divided by 125 is 2. You divide through by the smaller one. Yes. Now I will check.